Good afternoon, everyone. Thank you for joining us for today's afternoon session, Automating Your Cloud Security When You're Afraid to Ask Where to Start. Please give a warm welcome to Principal Security Architect, Security and Compliance for Amazon Web Services, Brad Dispensa.
That is awkward. Right on. Yeah. So I'll share an ironic anecdote with everyone. A couple years ago when Amazon first released the Amazon Alexa device, I was one of the first people at reInvent that did a security demo with it. And the demo I did was failing over a data center from the West Coast to East Coast by saying, Alexa, fail over my data center. Historically, at that point, I've always been involved with a lot of disaster recovery, business continuity. And last night, we had a flood in our house, and the roof leaked, and it leaked right between the G and the H keys on my laptop. The moral of the story is, I practice what I preach. I actually had a backup of the drive, which is why I'm able to present here with you today. Cool. So this talk is about automating your cloud security when you're afraid to ask where to start. So let's make sure that we are all in the right place, because I would rather you leave now slightly disappointed than at the end very disappointed. This talk is not for people that are hardened professionals in AWS. You know all the command line switches. You are a Python guru. You actively talk to the service teams on an ongoing basis. You are like neck deep in all things Amazon. If that's you, there's a lot of other cool talks going on right now. This is not your talk. This talk is for people that want to get started on that journey, that want to understand how to do security automation on AWS, but you're still coming up to speed. You're still trying to understand those fundamentals first. All right, there's not a mass exodus, so we're going to go. So the important part for security for Amazon and for a lot of our customers is around embracing automation and security. The reason that automation and security is so important is logically, humans, we're things that get tired, we get fatigued, over time we make mistakes, and automation, for better or worse, does not have that problem, right? Automation will run no matter what, whether or not it's working or not. So how do we understand where to start a journey then if we know that we need to embrace automation, but we don't know exactly where to start in that journey? So throughout the presentation, I want to try and interweave a bunch of shortcuts to the information that I'm giving you. So if you want to just sort of half gaze up every once in a while and check Facebook or something like that, it's not going to overly offend me. But these slides are going to indicate that there's something that's coming up that's a good shortcut for you. So if you want to pop the phone up and grab a quick screenshot of a URL, rock on, go back to the Instagrams or whatever else it is that you're passionate about. So the first one that's going to help everyone out is if you want to just get a quick, don't really care, just what was the gist of how I can get started really fast, this website. Our GitHub page for AWS Labs has a bunch of pre-made security automation tools, functions, little scripts that you can use. So if you don't care about anything else, this is a good, fast way to get a bunch of little scripts that you can start developing with and start playing with. But that's not really where you should start when you start thinking about security automation. When you think about automation, it's really important to not just run head first at trying to throw code at a problem, because that always ends badly. Instead, the questions that you need to answer when you start to evaluate that code are, what is my expressed security objective in words? And that sounds kind of like, no duh. But you'd be amazed at the number of times I've seen customers go headlong into a problem without really understanding what the problem is first and how they're actually planning to solve that problem. So it's really important that you actually first describe the problem that you're trying to solve in plain English. So don't make it overly complicated, just actually try to write it out. The next thing that's really important to understand is this a configuration or a behavioral attribute that we're trying to alert for in the security perspective? And that's really important because that's going to dictate the tools and techniques that we're going to use to drive our security automation, because they're going to fork as we start to look at the way that the code processes that information. The other thing that's really important is understanding that data. Where is it? Where does it come from? Is it coming from a log source? Is it coming from a different place? Where can I get that data that can help inform me about this thing that I'm looking to get information on? Another one that's often overlooked is, do I have the requisite ownership or visibility to get that data? So if you are a monolithic organization and your security ops have access to all the things, I can tell you why that's a horrible idea, but if that is your organization, maybe that's not a problem. But if you're doing work that relates to other organizations, or you're in a partner organization where you don't have access to all the data, it's really important to understand for the data that you do have access to, does it speak to these first points? Does it speak to being actually able to get that data and analyze it? And then also important is, what are your performance requirements? So understanding, is this something that I need to respond to in near real time? Is this something that's a compliance driver where I look at it every few minutes? Understanding what that performance function is super critical, because that's going to dictate the tools that we're going to use as we move on. And then ultimately, what mechanisms do I have to support all the information above, right? So for either self-made tools or for tools that you're using from a third-party solution, do I actually have mechanisms that can support this? And then ultimately, what is my expressed security objective in code? That's the last thing, right? So we started with describing it first, and then only at the very end is where we actually start to write code for our environment. So what we're going to focus on today is, I want to, in this case, what we want to do is start looking at some low-hanging fruit. So we're going to look at automating alerting for misconfigurations for a function of AWS called a security group. A security group is a stateful packet filter that wraps around AWS resources. So first thing that you have to know when we look at that sort of decision tree is, how fast do I want to respond to this incident? So if we need to do it ASAP, I need to respond in basically near real time to an event. The tools that I'm going to want to use are either CloudWatch Event or CloudTrail, or a Lambda triggered direct invocation. If this is something that we're looking at over time, so drift over time from a compliance perspective, then that's where we're going to look at tools like config. So how do we actually build out this environment? How do we actually build out this environment? So first, again, going back to the bullet lists, right? What is my expressed security objective written in words? So in this case, I want to know when a security group is created that is public. That is my objective for this exercise. The next part was, is this configuration or behavioral related, right? So in this case, this is going to be a configuration change. The next point is, what is the data, and where can I get it that can help inform me on this? In the case for AWS, this actually has a couple event sources that we can mine. So we could look at CloudTrail logs, we could look at a CloudTrail metric maybe that you have that's been pre-canned to do this. Maybe we are using just a default config rule that's looking at this capability as well. So that's the core function that we're looking at. And then the ultimate question on, do I have the requisite ownership or visibility into this? That really goes into, does your organization allow you to have visibility into those data elements that I just described? So can you see your CloudWatch logs? Can you see your CloudWatch event information, or is that information that's redacted from you? And if so, is there a mechanism that your security function, your code, can leverage in order to get access and visibility into that? So that goes into, can I create a role, or can I be given a role that has access to those log sources that we just previously identified? What are my performance requirements? So in this case, a misconfiguration of security groups can be a compliance issue. So in this case, I'm going to say, I want to know ASAP. I want to know, in near real time, or as darn close, that someone made this change to our environment, and I want to alert and remediate on it. Okay. We're all good on the scenario? All right. So now what? So you're starting this journey and you want to start to tackle this problem. The first thing I'm going to tell you is going to be the absolute most frustrating thing, but it's the truth. You need to read the manual just a little bit, right? It's important to understand the functions of the services that you're working with, so that you understand how to code around the features and capabilities of those services. I'm going to shortcut a lot of that for you, but as you start to build your own functions later on that you're going to see are on much, much more complicated design patterns, I can't give you all the possible switches and all the possible configuration attributes for a given service. So it's really important to crack that documentation open, because we tell you what all the flag switches and attributes are that we can use in our security automation. So First thing that we're going to do in this environment is I'm going to use a service called CloudWatch. CloudWatch allows us to get metric information about AWS resources, both from an AWS platform perspective, but you can also pump your own like log sources into it, sort of like a syslog type service. And in this case, what I'm going to do is I'm going to go into the rules dashboard. And what I want to do is basically go into the rule and create a rule first. The process for creating a rule is pretty trivial. So the first thing that we're going to do is basically say, where do I want this to actually trigger? What is the function? And in this case, a security group that we're going to target is based on an EC2 instance. And so for those that are not familiar with the AWS platform, EC2 is our virtual compute platform. So these are our servers, if you will. So in this case, I'm looking for emissions of security group information from EC2. The next portion is, where is that event source coming from? So what this dropdown really means is, where am I going to get that data from for this alert? And in this case, I'm saying I'm looking for API traffic that's coming through CloudTrail. Again, if you're new to the AWS platform, CloudTrail is a service that basically records all API calls on the platform. So if you're in the CLI, the SDK, in the console, all of that is actually an API, including if you're in the console, right? It's just fronting APIs for you in a GUI. So as long as we can see that API activity, we'll get it through CloudTrail. The next function here is basically where we're going to trigger on this. In my case, I'm going to do it on a specific operation, which is this authorized security group ingress operation, but it could be any. So it could be a star attribute. Anytime any EC2 verb is called, we can alert on this. And then you see a pattern that comes below. Hopefully, someone just kind of paused and was like, whoa, 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 back up. You just totally dropped a thing like this, like API attribute that was in there that I'm supposed to somehow magically know where that verb came from. Give me a break, right? So remember the document, right? So in this case, this is an example of where I could have gone to get that API reference material for understanding what are the possible attributes that are available for, in this case, security groups. So in this case, you can see in the API reference for EC2, this is where that authorized security group ingress comes from, and it also gives me all the metadata about that API call. So what are the things that are going to flow through it? And that's really important to understand when we start writing our Python function. So now we know where to look for, and we've got a trigger, right? So we need an actual function now that's going to fire when this actually takes place. So in that subscreen, there's a function to the right, which is the target. So in this case, the target is going to be a Lambda function. So again, if you're not familiar with the AWS platform, Lambda is basically the jack of all trades services. It allows customers to write code, and rather than deploying that code on persistent server infrastructure, you deploy code into the service, which basically allows you to execute a function and then detonate the function immediately. As a sidebar, from a security perspective, this is an amazing win, because that means from an attack surface perspective, there isn't, because basically the run lifetime is how long it takes to execute the function, which is billed in milliseconds, and then the container detonates. So shortcut. If you don't care about that and you just want to know, like, give me the functions, good news, there's a doc page that's available that has a whole walkthrough of how to create a custom CloudWatch metric that does exactly what I've just described, and all the possible verbs for all the possible permutations that you could use to be able to do this. So as I said, what you're going to see consistently both in my presentation as well as other Amazon security presentations is this Lambda thing is going to come up a whole lot. And the reason that, again, we do that is because it's so powerful from a security automation perspective. That's why you see it repeated through a lot of our sessions. So I've got an event, and now I want to do something with this event, right? So somebody went in, they changed a security group. What am I going to do? So the key places to start looking for that information, which was, in this case, the event fired the security group modification. What does that function actually do? So in this case, it's going to come from EC2. And what language or SDK am I going to be using to treat this function? You can use whatever language you're most comfortable with. In my case, I'm Pythonic inclined, so I'm going to use the Boto 3 SDK, which is Python, but we support a number of different languages, so just transposition if you don't like Python to Go or Rust or whatever your preferred language of choice is. So how do I find how to use Python and this SDK thing now. Good Lord, there's more stuff I have to do. Let me Google that for you. So in this case, I take those verbs that I just gave you. So I need Bodo3, I need to do something with EC2, and it needs to have something to do with a security group. Good news, top 2 hits are the documentation to Bodo3, which actually explains how to use these specific API calls. So in this case, the lower one will give us some information about working with security groups in Python. So walking through sort of that process for creating the function. So in this case, basically, we go into the Lambda console, and we're going to go and author the function from scratch. All you really need to know in this case is we've got our core function. We're not going to use the pre-made templates. A function name. So this is an oft overlooked little detail. Please make the name something that is meaningful to the community and not just to you. So calling it Sam's Awesome Number 1 means absolutely nothing to the rest of the team, right? Try to be descriptive in the name so that it's very clear what the function does, so that as you're looking through a list of lots and lots of these little operators, it's easy to kind of drill down. It's also really important from a governance perspective to use a naming convention or standard and try to stick to that standard. As a sidebar, you can actually enforce that in code, and we'll talk about how to do that at the very end, but it's a good little kind of call out. And then ultimately, what is the runtime? In this case, what is the language that the function is going to be written in? In my case, we're going to be leveraging Python. So quick shortcut, if you want to space out again for a couple seconds. If you want that code that's we're about to dive into, good news, you don't have to write any of this. If you go to that GitHub URL, there is a Lambda function that we wrote that effectively will do a whole bunch of security group analysis for you. So if you don't like the Pythons and you don't want to do a lot of coding, but you want to start on the security automation journey, good news. There's a function that's available for you that can help you with this process. So what does the code do? Like, what am I actually going to do with this function? So kind of walking out the data flow here. So we've got a non-compliant developer somewhere in your organization. And the developer, although well-meaning, has decided that, man, this thing is just not working. Like, I am sure it's those crazy network guys, and their firewalls are screwing up everything. It's always the firewall, right? So I'm just going to modify my code, and I'm going to say, you know what, totally cool, totes, we're going to open this up to the whole wide world. Port 22, right? There's no problems with that. Nobody ever scans port 22 on the internet. So in this case, the adversary, or pardon me, the developer, makes a call to expose a vulnerable port to the enclave. And in this case, we're going to first start with that event trigger, right? The API call that we created that CloudWatch event hook for a minute ago is going to see that the developer made a call to the security group, and it's going to go and do some sort of processing. Notice that that rule that I showed you earlier didn't say look for port 22 or look for vulnerability. It just said when this verb fires, point to this trigger. And it's the trigger that's going to be the brains to say what's actually taking place inside of this environment. So this wall of text is going to look very scary if you're not a JSON type person, but don't sweat it. We're actually going to dive into why this is pretty easy to read. All you need to know is that bottom port that I just highlighted there, right? Does that word look familiar to everyone? This is that verb that I talked about earlier, which is EC2, and then the event is authorized security group ingress. So remember earlier I told you the pattern that we were going to try and match on? This is it. And that's where it's actually coming from in the raw event data. So when you're trying to write your own security automation functions, this is just an example of how you drill into that massive output that's going to come out and start extracting those conditions that we're going to drill into. And then what we're going to do is we're going to pass this huge block of text into Lambda for processing so that we can start putting logic behind it. If you're new to writing code, or if you're a security operations person that's not a developer by trade, but like you're kind of good at scripting, if you want to come up to speed a little bit faster on using some of these other languages other than like PowerShell and Bash, good news, there's an AWS Developer Portal that speaks to the different languages that we support in the SDKs. So in this case, if you don't know anything about Python, you can go to the Developer Portal for Python. We'll walk you through a whole bunch of sort of like hello world examples and actual real world examples using the platform and the SDK. So this is a good way to sort of short circuit the, I don't know how to use the Pythons. We can help you with that part as well. So let's go back, make sure we're all consistent. What is my expressed security objective in code now? So I want to process that event data, and if the security group is open to the world, I want to get an email. So generally speaking, I'm doing this to make it simple for the entire audience to sort of ingest the process. Getting an email is actually really not a good security function, right? Because what are you going to do with the email? You're going to kind of dismiss it, right? Someone's going to be on vacation. No one's actually going to look at it. Over time, you get alert fatigue, right? Same thing with the traditional red light, green light dashboards. Everyone gets used to that one that's like red all the time. Don't worry about that one. That one's always red. Just ignore it, right? And that's what's going to happen to this email as well, right? If you know the answer to what you're trying to do, a big short circuit to the end of the presentation is code the solution to respond to it. So in this case, if you know that this is a policy violation and you know what you expect your engineers to do and it's repeatable, then just do it. Just make the code do what you want your engineers to do. As again, sidebar, the biggest problem that we face in our industry, Amazon and outside as well, it's really, really, really hard right now to get very good talent, right? We're all competing for a very small pool, and the pool is getting smaller by the day. The thing that makes people move from job to job is burnout, right? Nobody likes getting the stupid pager at 3 in the morning to respond to developer in some other continent just opened up a security group, go fix it, right? I am not getting up at 3 in the morning to do that. I will write a Perl function to do that for me, thank you. So let's go in and look at a little 101 example for how to do this. So again, if Python's not your native language, don't freak out. We're going to walk through what all this stuff means. The first thing is basically we're importing 2 libraries, JSON and Boto3. In the case of JSON, it's because I need to process that data. Boto3 because I need the SDK to use the functions that we're going to process after that. The next function is defining a function. In this case, it's a Lambda handler. And what we're going to do is we're going to process that event data and some context data that we'll touch on in a second. And effectively, what we're really going to do is do a loop operation to say, if the event name contains this authorized security group ingress, do something, right? So in this case, this is the brains of the function, right? So this first function basically says, of that giant wall of text that I showed you earlier, I'm looking for this pattern to somehow be existing here. And then the next function basically is what we're going to do to it. So everybody remembers this, right? So again, what we're looking for is that authorized security group ingress, but notice there's some other cool metadata below this, right? So if you're looking at the raw data, I have things like the source IP address of the caller, which security group it was that was actually modified, which port and protocol was used in this. These are all really useful data points that we can use to further refine our tool so that we can make it very targeted. In this example, which is meant to be 101 so that everyone can wrap their heads around it, I'm basically saying anything that has an open anything to anything world. But you can see that if we use those patterns below, we can make this very surgically targeted to look for specific patterns and conditions. So in this case, basically, I'm looking for any authorized security group ingress. And the response function here is basically, what do you want to do? What do you want to do when I detect this pattern inside of this environment? So in this case, what I'm going to want to do is detect that pattern exists. And then in this case, I'm going to use a function of AWS called SNS. SNS is our simple notification service. It has a whole bunch of really cool sub-functions that are not germane to this presentation, but one thing that it will do is send out topic notifications, which can include emails. So in this case, I'm going to publish to an SNS topic, and I'm going to give it some information about what occurred. So in this case, I'm going to send out alert that says for this SNS topic, which has been defined as alert name, security group has changed, and the attributes that I'm going to send to the recipient of this email is which security group was identified that has this misconfiguration in it, right? So you're going to open up your email on your phone and see that a security group was just opened up, and this is the SGID. You could then go and manually find it and try and process it and hunt it down, but again, that gets tedious, so later on we're going to talk about how to not do that. So again, the sort of callouts here is we've got the alert topic ARN. So for SNS, basically, this is just what is the Amazon resource name of the SNS topic. And then the lower function is I'm defining a variable. So in this case, I'm calling it SNS client, which is going to use the Boto3 library. And the client is SNS. So basically, within the Boto3 library, I'm looking for the SNS verb inside of that. And then the response basically is using that client, use a function of the SNS API, which is called publish, to put these data elements into the email. Everybody tracking? All right. So we've got our alert notification here. And then what we want to do next is we can send it out, but let's get a little bit more detailed. Let's go and kind of dive a little bit deeper into some more complicated examples rather than sort of the hello world of security. So there's a service that AWS operates called config. And right now, if you're an AWS user, you're probably scratching your head like, why isn't he just talking about config? Like, I don't get it. Probably could have done all this a lot easier in config. And that's true, but remember the decision tree. The decision tree was, do I need this to happen immediately, or did I need this to happen over time? If the answer is over time, config would have been the right choice, because config evaluates the posture of a resource in, let's call it 10-minute window increments. So within a 10-minute window, that's when we can detect that a resource may or may not be compliant. If I needed to know that the resource was modified immediately, I need to use that pattern that I described, which would have been using the CloudWatch event trigger. But if you want to know how to do it through config, I'll show you. Good news, all of it's already pre-built. So if we go into the config dashboard, all you need to do is we'll go into the rule dashboard, and if you just do a quick search for SSH, you'll find that there's a pre-made config rule that looks for looking for public SSH access to the environment. So I simply just search for that, enter it into the group. You'll see that basically I'll assign the function a name. So in this case, it's just going to be restricted SSH access. Provide a good description to your peers so that everybody knows what your new config rule is actually going to do. And then the lower function basically is saying, where is this actually going to take place? What is the trigger for this environment? In this case, the trigger is going to be a configuration change. So when the API gets evaluated to say, a couple minutes ago I saw that verb that you were looking for, and that means that somebody made a change. I don't know what they actually changed, but they did something. So in this case, the config rule will fire to reevaluate the posture of the resource based on having seen that that resource was changed. If that's not your game and what you want to do is just sort of be compliant from a timeline checkbox, the second object is periodic, and I'll make this easy for the Linux crowd. This is like your cron tab. For the Windows crowd, schedule task, right? So this is basically an operation that's going to look over time based on a window that you define. And then ultimately the lower portion is where we want to target. So what it will look like when you actually define and create that rule is this. So basically we've got a rule now that will go through all the security groups inside of my environment and give me a red light, green light, right? Compliant, not compliant. Do these rules violate that function? And when they are in violation, well, what flow are we going to follow? Good news, it's the exact same pattern that I just described, we're just using a different service. So in this case, we're going to use config. When config emits an alert, just like the prior example that we looked for a specific verb, when config emits that alert, we can use that rule with CloudWatch, just like the prior example, and we can use that as a trigger mechanism to process another Lambda function, but this time we want to actually do something with it. So in this case, what I want to do is not just send an email to everybody. I want to actually go and delete the security group change, auto revert. And I can do that because config knows the posture of the security group before it was changed and after it's changed, which is a really cool function because it allows you to basically see the provenance of all the changes for a given resource from its birth to its ultimate destruction and everything that it's ever interacted with, which is pretty deep. The other thing is, hey, remember that long screen of JSON that I showed you? Remember how one of the attributes was somebody's name? Well, I know the user that made the call. So let's then take that information and actually now lock out that user's account so that we can have a friendly chat with them about like, hey, did you know that company policy is don't expose command and control ports to the internet? So in this case, we're being just a little bit more proactive. So let's take it up just a little bit more now. To kind of gauge, I look for whether or not people are actively snoring or not snoring. So far, like nobody's snoring, so we're on a good track. There's another service that AWS offers called GuardDuty. GuardDuty is an automated threat intelligence service. So what we do is basically using the global visibility that Amazon has for running a product across the entire world. We have a really good sense of where bad things on the internet are. We also have a partnership with Proofpoint and CrowdStrike, and we aggregate those threat intelligence feeds together to allow customers to, without having to develop customized tooling, alert when something inside of their environment does something bad. So let's make it plain English. I have an EC2 instance that's talking to a known Bitcoin mining API endpoint. If you don't do a lot of cryptocurrency research or cryptocurrency development inside of your environment, that's a pretty good indicator that you've got a box that's popped, right? I'll also make it really easy for everyone. If Amazon isn't actively investing in a function, you can bet that there's no money in it. So in the case of customers evaluating whether or not cryptocurrency is valid or invalid for most environments, we don't mine cryptocurrency on our own infrastructure in terms of making it cost neutral, so probably you shouldn't either. So for most of our customers, anything Bitcoin related is invalid. So GuardDuty can alert us to say, hey, I detected that this EC2 instance is talking to this known nefarious point on the internet. The pattern is the same that I sort of described at the outset, right? GuardDuty will emit an alert to CloudWatch. And again, it won't say this resource is talking to a bad place on the internet. It just fires an alert to say, hey, I got a hit. What your logic will do is follow that same Lambda function logic that I showed you earlier. There's a conditional statement, and the conditional statement will say, show me the function, show me what actually happened inside the event. So let's break this down. Looks familiar, right? So we've got a pattern. In this case, slightly different. The event pattern, is that we're using GuardDuty now, and the event type is a GuardDuty finding. So you can see in the event pattern, basically I'm saying anytime GuardDuty has a finding, I want to process it with a Lambda function. So what is the Lambda function in this one? So to kind of quasi-demonstrate how easy this is, I showed you sort of the 101 example. This is a subset of a real Python function that I use with one of my customers. So this is roughly 9 lines of Python. And effectively, this will allow you to auto-terminate an EC2 instance when you find an instance has been compromised by, in this case, command and control activity calling out to a known bad place via DNS. So the response element here could be terminate EC2 instance. But let's make that a little bit more feature-rich. In this case, instead of just doing a terminate instance, which would destroy evidence, we can also fully automate the incident response pipeline to recover that information and start staging it for our IR toolkit. So in plain English, you're an NCase or FTK shop or your forensics tool suite of choice. Most forensic investigators are way, way overburdened, and we're looking at the same kind of burnout issue, right? So if we can do all the acquisition of information for that investigator so that when they go to actually sit down to perform an investigation and they're not performing acquisition, this is a huge win to help prevent that burnout from these very, very key resources. So in this case, what we can do is, because everything on the AWS platform is an API call, I can use that sort of mental model that we laid out at the very, very beginning, which was describing our problem and saying, well, what would the incident responder do? Well, I'd snapshot the EBS volume, the block storage volume attached to the hard drive. Okay, well, what else would you do? I would run some commands on the operating system to get information about processes running. That's going to be tricky, but we'll get into how you could do that too. So let's go one sort of layer deeper into that sort of dark place on the network analogy. There's a really neat functionality of AWS called VPC flow logs. And for the network folks in the room, half tune out, this is netflow, right? So you've seen netflow information before. Cool thing is that netflow information is flowing through that CloudWatch service that I described earlier. Because it's flowing through that service, that means that we can analyze that data, right? So what we can do is use that data flowing through CloudWatch and start creating custom metrics. So what does that mean? So I can create a metric that starts looking at specific reject calls in that netflow data. In this case, I see rejects that have port 22 open, right? So this isn't a hypothetical anymore. This was an actual call, right, in the network packet. This is port 22 actively being rejected on our network. Then what I can do is basically create a custom alarm. Now, the alarm alert threshold varies by customer, but in this case, we don't use SSH at all in our environment. So I can set the metric to basically be anything other than 1, right? So if I see 1 or more of these rejects in our environment, then I want to do something. But notice I'm doing something different this time. Why am I going to SNS instead of Lambda? I just told you that all the automation coolness happens inside of Lambda. Well, remember I told you that SNS can give you information like sending out to an email, but SNS can also be used internally as sort of a pub-sub model. So what that means is rather than sending that data to an email, I can send it to a process that will start to fork that information to other processes. So in this case, instead of sending it to one giant monolithic Lambda function, I can start sharding that data out to multiple Lambda functions. So in this case, I can have one Lambda function that says, this occurred. It will go and disconnect the Elastic Network interface from that EC2 instance. For the non-Amazonians, I'm going to unplug the NIC from the network. But in parallel, at the exact same time, if you're using a large-scale ticketing service, ServiceNow, Remedy, any modern, mature ticketing program, they have an API exposure, I can start opening up a ticket in real time that gives all the metadata about what just happened. And not just that it happened, but I can see the acknowledgement that, yes, the API call to disconnect the ENI was successful, and here's all the information about the investigation so far. auto-injected into the ticket. So again, we're reducing that operational burden for the folks that are actually in the field. So this has all been sort of like high level, okay, that's cool for one account. What happens when I got a lot of things, right? Like we're on Amazon, we're all in on Amazon, we've got like tens or hundreds or thousands of accounts. Like this is a really cool, bro, but this does not work at scale. Good news, actually it does. So the way that we do this at larger scale is through a service called organizations. For the sort of non-Amazonians in the crowd, what that means is organizations is a service that allows you to create effectively topologies of account structures in a service. So for the Microsoft inclined, this is like Active Directory, but for accounts, right? I've got a root domain, so a root of this forest, and then I have sub-OUs. And then within that OU, I can have nested OUs. And in those OUs rest accounts. And just like in an Active Directory environment, I can apply policy to the root, to the OU, to the sub-OU, or to the account. And that allows us to do really, really cool granular controls. So playing this out, let's say that we've got this nested topology of accounts, and somewhere in that space we have a dedicated security account. So this account is used for performing specific security operations on the platform, like I want to be able to go in and interact with accounts that the company owns, but I need a safe way to do that. In larger enterprises, AWS has a function called the Identity and Access Management Portal, which allows users to define IAM users. But for a large organization, a mature organization, you should never use IAM users. Instead, always use a form of federation. So if you're an AD shop, you can use ADFS. If you're an SSO shop, we integrate with all of them. So think, Okta, Ping, pick your flavor. All of those will allow you to go using a single sign-on solution into the platform, and it will assume a role to perform those same operations. Without going deep into this section, because this is a completely different talk, role-based access is really, really important because remember in the very beginning I told you everything is an API. Well, if you know anything about APIs, you know that the only way an API will complete is if it has keys. So I need an API key to authorize me to make this call. Well, when you have IAM users, those keys are static. And the problem with that is that users are well-intentioned, as we've already described, but they get tired over time and they don't do things that they should, like rotate those creds. So if we use role-based access, Amazon behind the scenes is actually rotating for you every so few times an hour. And so the benefit to that is that basically I can temporarily assume a role to get me access to a function or to an account, and then once I'm done, I close it. So I like making analogies for the Linux crowd. This is the equivalent of using like sudo, right? I'm going to temporarily bump my permission to get more for what I need to actually do, and then I drop it. So in this case, I can use that to do things like publish SNS topics that those accounts can listen to. So topics can also be consumed by those accounts. So in plain English, what that means is I can do things like put that event that we just saw in the prior example, that something bad happened in one of our VPCs, but I can see the external caller of that actor, the IP address of that actor. And using that in conjunction with GuardDuty, which also provides you information about geolocation, the ISP, the ASN of that network, I can start transmitting that data out to every single account in our organization to say, hey, does anybody else see this actor in your network right now with an active connection? Likewise, we can also aggregate all of that API activity via CloudTrail into one central place. So the reason that that's important is remember that CloudTrail records all the API activity. So a clever attacker, what's the first thing that you're going to do when you get access to an account? You're going to try and turn that off, right? Like I want to mute the log so that you can't see what I'm doing. Technically, the right way to deal with that is that we can apply a service control policy that would deny that capability. But the good news is that because all that log data can be centrally aggregated in a separate account, if a clever adversary goes and tries to delete that log information, they can't because it's being stored centrally in your central security account. So that all said, let's turn this thing up to 11. So what we can do with organizations is there's a really, really cool function within a service called CloudFormation, which is, allows customers basically to describe all of the AWS infrastructure as code, called a stack set. So stack sets are pretty cool because basically everything I just showed you can be deployed in a CloudFormation template. But more powerfully in a stack set, what that means is I can start sharding it to every single account in the environment. So let's make this a simple example. I want to make sure that everybody's got this logging thing on that Brad was talking about, CloudTrail. I want to make sure it's enabled on every single account. Well, good news, we can go into the stack set. There's a pre-made one for enabling CloudTrail. We ask you to basically populate a few simple attributes, and as a developer, you can define these attributes for your end user to allow variability in how the template is ultimately going to be deployed. But in this case, I'm just saying, what do I want to call this? Does the log file validation function need to be enabled? Is this a multi-region function? Do I need to broadcast to an SNS topic? And then really neat, it will allow me to define the stack set to every account or to targeted accounts inside of my organization. So I can do it based on an OU, so all the ones that are part of a regulated control framework. We want to deploy a specific Lambda function that looks for violation of PCI. I don't need this for every single account, but I do need it for the ones that are in that secure OU. I can focus it just on that OU or to every account in the organization. Likewise, not every customer uses every region that AWS offers. So if I want, I can target the deployment into specific regions rather than shotgunning it to every single region that the environment exists. So let's make this make sense. So in this case, I've got a CloudFormation template that we're going to deploy as a stack set. And what I want it to do basically is create a default security group in every single one of our accounts in the organization so that people don't have to guess at what those approved CIDR ranges are. Because I forgot the memo. I don't really know what CIDR is. So I'm just going to put the zeros because that looks pretty. In this case, what we can do is give them a blessed security group by the Security Operations Center that has those pre-approved CIDR ranges. So what does it look in deployment? Basically, we can put that template into an S3 bucket and then blast it out to every single one of the member accounts inside of our organization. But the nice function is we made a mistake. We deployed this and it totally broke prod in these 3 accounts. We got to roll this thing back, like now. So cool function, you can delete the stack sets as well and target specific accounts that you want to roll this functionality back from. So in this case, when we go to deploy security automation at scale, what we can do is basically use this to blast our function that we just wrote, our Python function. But if we see that it's breaking changes in accounts, we can quickly roll it back from those specific accounts. And the really cool reason that you should use CloudFormation is CloudFormation knows all the parent-child relationships of the code, so it knows everything that was deployed as part of this. So you don't have to guess like, oh wait, did this have the 1 script or 2 scripts? The stack set knows all the entity attributes that are related to its deployment, so it will roll everything back that it deployed. So in this case, basically, I would roll back from account B and say, totally broke prod, my bad. We'll take it away from you. So what's next, right? I've given you some sort of high-level examples. So if you're new to AWS, this is your turn to go heads down. If you're more seasoned in AWS, this is your turn to perk up, because we're going to get kind of technical, kind of deep, kind of quick. So I apologize if you're sort of newer to the platform. For those that are more experienced and want to know how to start really up in your game on the security automation scale, this is how you do it. The first thing that's super critical is observation. You cannot write tooling and automation if you do not know what you're trying to automate against and you don't know what your adversary is actually doing. And this sounds kind of 101, but again, how many times have we heard time and time again that logs weren't enabled, that we didn't look at the log source, that we had it, but there was nothing that was actually processing it. So observation is super, super key. So the problem that I see customers make when they do this sort of observation model is that A, they're not looking at all the data that they have, because basically every AWS service emits a large amount of logs that you can process and ingest. And they forgot to check that X function was enabled. Like, oh, my bad, on this one account, we totally forgot that we made this one breaking change because we had to do it for this one customer. VP was really angry, so we had to do it for this. So now you've got this sort of snowflake resource that's floating out there. So why do people not do this? The reason that I hear most frequently is sort of the unknown unknowns problem, right? I'm new to the platform. I have no idea what I'm supposed to be looking for. I don't know what I should be looking at, what normal looks like. I don't know how to define those codified processes. So it's important to check your assumptions in code. So in this case, what I can do is use that cross-account role to say, I want to make sure that every single account inside of our environment has CloudTrail enabled. Rather than relying on good intentions, I can use that role to blast out an API call to all the accounts and say, show me your current status for configuration for CloudTrail. And in this case, basically, I can validate that, yes, CloudTrail is actively configured correctly and that it's pointing to the right log source. From a Pythonic perspective, and I apologize that purple doesn't show up on a black screen, this is sort of an example of a simple CloudTrail lookup where basically I'm saying, does the CloudTrail element exist and what bucket is it actually pointing to? Likewise, I can do the same. Oh, purple again, my apologies. What we can see here is that I'm looking for the same functionality, but is VPC flow logs enabled, right? So fairly simple processes, basically just check those functions. The reason that this is super critical, though, is that when we make these micro functions that are very, very simple in nature, it allows us to use them in a repeatable way. So what that means is that basically I wrote this one simple function, this elegant thing, that others can use as effectively a library in their code. So they can start to create these sort of library-based deployments that say, oh, I need a function that does a quick VPC flow log dump. There's this one. Use that one that does all the dumps for us. So as an example, from an AWS security best practices perspective, on page 70, we say log everything and alert based on a given threshold of the policy, right? So we want you to use core functionality like VPC flow logs. We want you to constrain security groups to least privilege so that they're not open to the wide world or where they're not appropriate. And the response I see overwhelming from customers is that they look for patterns that they already know, right? They use the low-hanging fruit example that I've been using ad nauseum through this entire presentation that I'm sure is aggravating at least one person in this crowd, which is port 22. We don't use port 22. We know that's a dangerous port, right? So you're looking for the bad thing that you know is bad, but you're not looking for the other thing that's starting to detect patterns that are anomalous in your actual environment. So how do we deal with that? So the way that customers usually address this is this kind of simple function, right? I'm going to do a scan through all the VPCs, and I'm going to look for all the security groups, for all the IP permissions, for all the port ranges. In this case, it's sort of a nested function looking for port 22 open, and it has to have this CIDR open to the world function, right? Like simple sort of deep dive on this little function. This isn't bad per se, right? It is addressing a threat. It's addressing a threat that's known and understood. The problem is that this isn't addressing a threat that is evolving, right? So from a bad idea perspective, this doesn't take into account that this could be normal for your environment, or what happens when this emits an environment that has never done that ever before. So one way that we can address that is with a service called Systems Manager. So Systems Manager will allow customers to basically remove command and control access through command resources like SSH or a remote PowerShell from the Windows crowd, and allow you to do those remote functionalities via API. If that's not sparking your interest as amazing, what that means is remember that it's an API, and that means that it's logged. So that means when I emit information to the service like keystrokes, I'm getting a keystroke log, right? So I can tell what an operator is actually doing using the service because I'll actually get that information captured in the Session Manager output. The other nice part is from an attack surface perspective, your QSA, for those that are PCI inclined, will hug you. And the reason they will hug you is because you will no longer have an active listening port or process on this for getting that telemetry. So even if you're using common third-party tools that provide customers with information about what libraries are installed, what packages, what versions, almost all of those require you to have a listening process on that box, and that process must be exposed to some IP address, even if it's an internal one. This does not. This uses internal APIs to basically allow you to get that telemetry information and to execute those commands without a listening process. So let me make this super easy for everyone to wrap your head around. I can create an EC2 instance with no network connection whatsoever, get on the box and start typing shell commands to it, because I can use the agent to basically forward those commands to the resource rather than having to go through the public internet. So super game changer. Also, because it's an API, that means I can tightly constrain who has access to that and under what condition. So it's not just Brad is authorized to assume a role to get access to this function. I can add sub-conditional statements to it that says, and you have to be coming from corp IP space, and it has to be during business hours, and there needs to be a ticket attached to the key ID in the resource so that we can track why you did this. But going back to the sort of problem that I was describing earlier, the reason that this is still not super great is that it's not addressing change over time. So what we need to do to sort of step up that game is start looking for not what we expect to see in our environment, but what we actually see in our environment. So can we look at multiple data sources and combine information from multiple places to start to better evaluate risk inside of our environment? So in this example, what I'm looking for is looking for abnormal traffic patterns. So I'm simply processing VPC flow logs, And in this case, I've got an internet gateway, an Elastic Load Balancer, and 2 web instances. I expect all web traffic to flow through the Elastic Load Balancer. There really shouldn't be any east-west traffic at all in these resources. But in this case, I've highlighted a single flow that indicates web instance 1 has just tried to initiate a communication to web instance 2. It has no bearing on what port or protocol it was using. It tried to do it, and I get a reject in the VPC flow log, right? So now I know, regardless of what it was doing, this tried to talk to something internally that has no business talking from east to west. What do I do? So in this case, use that workflow that I described earlier, which is the second that that fires, I can fire a CloudWatch event that says, whoa, no east-west traffic. Immediately go fire a Lambda function. And this time, the difference is I'm going to use Sessions Manager. And the reason I'm going to use Sessions Manager is because I can go and start actually executing commands on the box. So I can start sending commands to the resource like, hey, give me a network dump of everything that's on this box right now. So I want to do a netstat for all listening processes. I want to do a netstat looking for a specific process comparison over time. I want to do a process listing, so PSAUX for the Linux crowd. So now I'm getting much more metadata, not just that this resource was trying to talk east-west, but here's everything that's actually running on the box, and is this normal for this particular worker fleet? So in this case, we detect that anomalous flow using that process, and what we can do is basically say, I can combine the VPC flow log information with the Sessions Manager output to say, yes, this has an unknown process running, which is a Tomcat server that we don't run in our organization. So now we've got a high signal to noise ratio that this is a compromise, right? It tried to make a call east-west, that was the first thing. And now looking at the box, it's running a process ID that we do not use internally. So now we can zero in like a laser and say, like, this box is popped, let's start that automatic remediation workflow. So can we automate this automation? Good answer is yes. And the nice part is that if you're not a machine learning specialist, good news, we have a service that'll help you. SageMaker. SageMaker has a built-in function called IP Insights. And what IP Insights will help you do is basically perform this same type of analysis, but over a much larger data set, including, if you don't use only Amazon, you can import other netflow sensors into this to perform the exact same anomaly detection of those netflows. So I can look for high signal to noise of particular malicious events, and I can also correlate that to large spikes in traffic that are legitimate events. So plain English. We made a really killer marketing deployment, and people are going crazy for Acme Co widget. And so we see this massive spike. If we relied only on information like high spike means high compromise, we would start taking off resources that are legitimate traffic. But because we can pass additional metadata to the alert, like, is there a marketing program active right now, and what namespace is it using? I can say, okay, I'm going to reduce the confidence interval on that now because I'm seeing a huge spike in traffic, but I'm also looking at the separate data source that says there's a marketing operation taking place specifically on that product right now. So what does that look like sort of ramped out? I can use the simple notification service with AWS Lambda to start taking all that information and aggregating it into a single, let's say, IP ranges JSON file that gives you information about real-time bad actors internally and externally in your environment, and then start to shard that out to things like your load balancers. So let me make this a little bit more visual and simple to wrap your head around. You've got your security account. Security account is processing all this crazy network information. I've got my SageMaker running, I'm looking for crazy flows, and I detect a hit. We've got a bad actor somewhere in one of the different namespaces in one account inside of our organization. When that hit occurs, I can use an SNS topic notification to shard out to all the resources, and a Lambda function on those accounts can process that topic notification to say, hey, IP bad actor, go scan all of your IP ranges looking for this bad actor. When that comes back, I can send telemetry back to that central account to not just say, mission accepted, I've gotten my resource, but I can do this bidirectionally. I can say, yes, I got your payload, and no, I don't see these actors, or more importantly, yes, I've got an active flow on one of these resources, or I've got an active security group that includes that IP range in its CIDR prefix. And then from there, I can do automatic blacklisting of that CIDR range. So I can specifically blacklist actors as they start to emerge from their basement in the internet somewhere. So the important part is that this is all really just the beginning. So I'm only starting to scratch the surface of all the crazy automation that you can do on the AWS platform. But it all stems back to that first 101 example that I gave you, which is think first about what you're actually trying to do and really walk through trying to understand verbally in your team. Talk about what it is that your assumption is that this is actually going to do. Look at all the data that you actually have access to and make a decision about whether or not you can actually do the thing you want to do. And then the last step being write your code, right? And the big takeaway, I guess, for this presentation is the biggest mistake I've seen customers make historically is they jump to the last step. And the reason that that sort of ends badly is because in that early design phase, it allows you to do branch logic within a group to sort of say, like, did you consider this possibility? Or did you do something simple like add error handling to your Lambda function? If you looked early at some of my examples, I totally glossed over the fact that I had a small error handler at the end. That's a common rookie mistake that a lot of customers make, is that they don't put logic like, what happens when the output is not in a format that you expect? Like, what happens when a service is down and we return a, nope, can't help you, right? Do you have logic in there that'll actually break and process that data? So that's all I've got for the automation part. I'm more than happy to hang around, ask questions, answers, hang out. Yay. So I hope everyone had fun. Hope this was helpful. Again, like, don't feel weird about coming up and asking questions. But otherwise, hope you all have a great conference, and best of luck.